Everyone will give people a few minutes to join.
Hey, Joe, do you want a readout from the board meeting that happened on Monday?
Sure.
And then I could use a few minutes to talk about the template and the need for technical folks to submit any diagrams they want the Linux Foundation to kind of standardize that will go in in the deck.
Yeah, no problem. All right, I think we have enough to get started. So go ahead, Paul.
Sure. So, a readout from the board meeting. Let's see. The agenda was there were no anchor topics, but we did readouts from TSC and Outreach Committee, Outreach Working Group. I'm changing that. And we did, Sridhar did an OPI by numbers readout. Let's see, we discussed in the technical committee update, we discussed the lab and what's happening with the latest lab status, informed the board that there was still a legal wrangling going on between Hurricane Electric and the Linux Foundation. Sridhar, it seemed like they were close on that. They've come to an agreement, and it's just putting it in writing and signing it.
Yes, rather we have come to an agreement. Yeah, so we have added a condition. I think they have agreed now. It's just a matter of signing it.
Good, perfect. So that was that. The Outreach Committee working group gave an update that really the update is that from Marvell, Jeffrey Ho has been tasked with being on the Outreach Working Group from Marvell. He's been assigned to that. We talked about the business development proposal that we had received from the Linux Foundation, and that we decided we will review that and take it up at a later date. We're not quite, we don't have the content nor the resourcing to take on an effort like that at this point, possibly by the end of the year, into the summer. We reviewed a press release that is being worked on right now and updated the board on the website, branding, presentation template, and an introductory slide deck that was being presented. Sridhar then talked about OPI Insights and the dashboard that the Linux Foundation is working on. showing the total number of commits and the number of contributors, and from where those people are contributing, how many lines of code have been added. It's a pretty interesting dashboard, and we can use that in some of our messaging as well. And that was pretty much unless I'm missing anything, Sridhar, was that the update?
And yes, on the TSC, what we did was we used the same meeting minutes for the last 3 weeks and focused on the important topics. Especially, we gave an update on the Dash engagement. How the discussion is going? How Christina attended one of these calls and gave a presentation on the Dash, and also on the lab equipments. Where we are now. What are the things that we already collected? So we just walked through, use this meeting minutes itself, and thanks to the excellent process that you're following, these minutes helped us to walk through those TSC updates.
Yep. Perfect. That was the.
All right, let's do the outreach real quick, and then we'll drop into
Sure.
Dan Daly and IPDK plus Dash.
Okay. Can I share real quick and show you something?
Of course.
So we've got a slide deck that we have been building, and we're good with the graphics and everything until we get up to these more technical graphics that have come from the members of the TSC. What we need to do is a graphic like this one, graphics like these. We need to make sure that they are still correct. So I'd like the TSC to take on reviewing these graphics, providing updated ones if we have them, and providing new graphics that have been created since the last, I think 6 months was the last time we added graphics like this to this deck. So I'd like to get those from the TSC members, from the technical community, that we can put in this deck. And we will have the Linux Foundation then start normalizing them or making them similar, doing things like putting the font and the colors and the schemes and that sort of stuff on it. Coming up with things like, do we want boxes with square corners or round corners, or does it matter? Have them do that sort of thing. I know that we want to use draw.io as the method which diagrams are created. So we'll have them come up with a template that can be used in draw.io. I think that works. We'll find out, but that's the initial plan. But before that, I need new graphics and updated graphics and validated that these are the proper graphics to keep in the deck. And what I will do is drop this into the chat. You can put it in the meeting minutes. That is where that deck is located.
All right.
And that's what I need. So if the working group leads can pass that out as a task to someone on their particular working group, that would be great. I'd appreciate it.
All right. All right, Dan, do you want to share?
Yeah, I'll share. Let me maybe, let's see. Yeah. Can you see this?
Yep.
Okay. I am going to run through some of the different interfaces that we're using in IPDK today. And then I invited Reshma here. She's going to talk a little bit more about the things that we've been doing with Sonic and with Dash. But in IPDK, we have these two interfaces. We have this application interface at the top, which is primarily centered around P4 runtime. We also have different interfaces that use OpenConfig. And at the bottom, there's this target abstraction interface that uses different interfaces for moving data around, and for configuration on the networking side, it uses this interface called TDI, which stands for the table-driven interface. It's a spec on the p4.org that is different from P4 runtime in that it is it's a functional interface. So it's very fast. It's can be C or C++, and it is programmable in that you can specify a set of P4 tables and get tables into the TDI via the compiler. It also can be used to specify fixed function tables. So your port table, QoS table could be a register table. And I would say that the big difference between this stack of interfaces and Sonic today is this introduction of the TDI underneath Psi. So earlier, I don't know if people are familiar with this project called PINs. There is a project, Intel, Google, a couple others worked to integrate P4 runtime into Sonic, and the focus of that effort was to convert from P4 runtime to Psi, and that was really valuable. And we use a lot of those concepts here. You'll see later in the deck, but that was converting a programmable, like if you had an existing P4 runtime compatible controller and you wanted to use a Sonic box, it would convert P4 runtime to Psi. What we do here is we convert Psi to TDI. So we're converting from a fixed function spec Psi to a programmable spec TDI. And that's really the basis for this stack up, is that by having TDI at the bottom, having a programmable a way to declare the intention of the application and program it into the target, it enables the ability to simultaneously have different applications running at the same time, depending on the set of applications that you need to support. And so that's how we're able to support these different types of apps, is as it sort of Blink goes down through the different layers, when it gets to the target at the bottom, it's a programmable interface, and we support this TDI in our software target on IPDK. We support it on our IPUs, and it originated from the Tofino programmable switch. So what we're doing is start from TDI at the bottom, and then we use the Psi to integrate with the Linux kernel. So layer 2 bridging, layer 3 routing, tunnels, these types of things all go through Psi. So a lot of the Sonic functionality that you would expect, we implement it in a really similar way in IPDK. And we did that on purpose to make it easier to make it a choice between, let's say, an OVS or some other vSwitch and Sonic in the future. So if you look at the way we did OVS or OVN, let's say OVM at the very top uses OVSDB to configure a tunnel, or maybe to create a layer 2 bridge. That will go over OVSDB into OVS. OVS, when it does a tunnel or a bridge, will actually call into the Linux kernel and put that into Linux. We will listen to the netlink socket in Linux for that configuration, and we will call a SCI interface to configure that. And then at the bottom, we're going to convert from SCI to TDI into whatever target you are connected to. So, that's sort of a top to bottom example of how, there's no P4 necessarily in that path, but we're using that programmable TDI interface at the bottom to be able to support those existing fixed function standard interfaces. So really, I think that our proposal to OPI would be to take the next step to explore the use of TDI in the networking of OPI would be the place where we would support different implementations, different vendors, software versus hardware, ASIC versus FPGA. You have all of these different options that can be supported at the TDI level. And from an application integration perspective, we can sort of decide which of these application integrations we want to reuse. But once you have that sort of TDI at the bottom, then that gives you the flexibility to be able to have multiple different types of implementations. So I have a whole set of slides to go into more detail about each of these different stackups. But I want to make sure we have enough time for Bipin and for Reshma. So questions or areas you want me to dive into?
So if I understand correctly, you're saying we'll have vendor agnostic interface both on top of the infrastructure application interface, such as SCI, OpenConfig, and so on, which are standards. And now you want to also abstract the underlying API with this TDI. Is that the suggestion?
Yes.
And why having the northbound API here as a standard is not sufficient?
I would say that that's certainly an option if we just wanted to standardize the northbound interface, and that's what we've done thus far in the API group. But that doesn't really sort of enable a multi-vendor solution. It's not that hey, we have an application interface at the top. If you support it, then yeah, everything should be fine. It doesn't really give you that. It doesn't really give you that multi-vendor solution. So this TDI at the bottom is a great start because it allows us to have a clean separation between all of the vendor data sheet secrets, dirty laundry that you don't necessarily want to put into open source. You can have that below the TDI, and then everything above the TDI you can have in open source. So you can leverage, share, and reuse all of the code in that light purple, and that's all the code that we have on IPDK.
So all the vendor specific will be below the TDI, which won't be open source?
it could be open source, but it gives you the choice of saying, I'm going to keep the piece underneath the TDI proprietary, or I'm going to keep the piece underneath the TDI open source. So for example, our software target underneath the TDI is all open source. Our other targets are closed source, but certainly in the future, it's an option for any vendor to put a hardware TDI backend in the open source. It's really up to them.
But wouldn't we be adding just another shim layer? I mean, I'm looking at the stack that we will be building here. We will have, for example, Psi, which is translated with Psi, which is standard, translated to TDI, which is standard, and only then translated to a vendor specific. So why do we need 2 layers of passing vendor agnostic till we actually get to the hardware? And I'm scratching my head and thinking what would be the impact on performance, let alone the code that we will need to add here.
All of the target, we'll go through that in a bit, but everything at the target integration layer is C, C++. It's extremely fast, especially when you think about, Sonic having a Redis database and P4 runtime having gRPC. These things at the top have other performance issues. When you get down to target integration, this is where you can do millions of updates per second. So we don't have that same type of performance issue at the bottom. And Psi, let's say we just wanted to do Psi. Problem with just doing Psi is that it is a fixed function interface, so that there's unless it's defined in Psi or in Dash, you can't do anything else. And so TDI is just that layer underneath that is merging the fixed function operations in Psi, Dash, and OpenConfig together with the programmable interface at P4 runtime.
But isn't it true that the OpenConfig mostly come through one of your application integrations anyway? In other words, or let me ask it as a question: which OpenConfig models go directly to TDI?
Let's take the OPI security stack up. So in OPI security today, OPI security is a front end for the VC Strong Swan interface.
Yep.
So OPI security calls into Strong Swan. In IPDK, we've created this plugin in Strong Swan that calls P4 runtime for the flows and OpenConfig for the keys. And so in this case, you use OpenConfig, it will convert the OpenConfig gRPC directly into TDI. So that's an example of where OpenConfig is converted directly.
So for the keys, right? Because OpenConfig covers all of networking. And if I want to do something basic like configure an interface or configure a VLAN, that would actually go to OVA. Basically, that would actually go to OVN or Sonic or FRR. I mean, I want to configure BGP, it's going to go to FRR, right? It's not going to go directly to TDI.
That's right. So OPI security is an example where, OpenConfig is very nice because it can have different layers of abstraction. But in the security case where we're just doing keys, that's OpenConfig directly to TDI, where there are cases like with the FRR, it will have some OpenConfig, goes to FRR, and then FRR will program something that will go through the Linux kernel, and then that gets programmed through Psi.
BGP config turns into a set of netlink events, which turn into Linux, or they go to Linux kernel updates, which turn into netlink events. The netlink events then get turned into Psi calls.
Yeah, and so this is sort of like a configuration Plinko, but what's nice is that the thin middle at the bottom in between the targets at the bottom and all of these layers at the top is the TDI, and that makes it easier to sort of sort out. And there also can be cases where maybe there's in the upper layers, there are multiple ways to say configure LACP, to configure your lag. You could come through OpenConfig, you could come through the Linux kernel, you could come directly through P4, you could come directly through Sonic. So there's lots of different ways to potentially, for certain configurations, to configure effectively the same table in TDI.
Yeah, and you showed dash calling TDI, but dash nowhere else. That can't be correct, right? Because we know that dash calls Sonic for some of their configuration. Because if I'm going to configure VXLAN, I'll use Sonic directly.
We'll show you that layering. So what we did was we wanted to have dash at the very bottom for performance reasons. So we wanted to make sure that you could call into dash. Dash would convert directly into TDI, and so that you can do those dash operations at millions of operations per second. I'm stealing Reshma's thunder here, but
well, that's okay. Okay, so we can. Yeah. Okay, we can wait till we see the next part of that. So I guess what I'm trying to do is the same thing that Tazi is trying to do, which is, adding one more shim layer in these architectures might buy you something, but you got to worry that you're just creating yet another SI that you then have to abstract again later on. And we have this, every couple of years we re-abstract and relayer, and who knows when that ends. That's part of the consideration, where the combination of SI and P4 runtime were supposed to cover all the bases. At least that was what was said originally. Now we know that SI is a bit inflexible, again, in that you can't just do whatever abstraction you need for the upper level interfaces. It's all got to be ratified, and it's fairly rigid and so on, although it covers most of what you need to implement a L2, L3 switch. So you think TDI is good because it's general, because it's basically just match action tables. Yes. And B, if we have a fixed mapping of dash OpenConfig P4 runtime and then obviously SI to TDI, then for at least those things that are defined, you don't have to do any additional work if you produce the equivalent TDI, which is, of course, what SI said originally, which is why there's any discussion. And don't get me wrong, part of this is just devil's advocate so that everyone understands the decision point that we're trying to drive here, Dan.
Absolutely, yeah. And I agree with our current approach, which is to start at the top and get those application interfaces right. But the reason for existence of the TDI is to be able to bring all of these programmable flows and these fixed function flows together, so that all of that, whatever interface Plinko that is happening here, can be in the open source standard. And then if I'm a new device or whatever, I have this interface at the bottom that is the what I need to support in order to be able to snap into this framework.
All right. Any other questions from anyone before we move on? We'll have to come back to this, I'm sure, but before we hear more information, any other questions? Tazi, is that a little clear, at least on what the approach is, the description of the approach?
I'm just maybe want to add one more comment. I know from our experience with P4 that any extra layer for P4 runtime is a penalty hit, and there is a really high effort to reduce line codes and and structures rebuilding from one to another just to optimize. So even on the performance level, I'm very concerned.
So at the P4 conference this year, Google presented something called P4 Runtime Native, and it is P4 runtime without the gRPC. So it's a very promising development where they are. It's very common to have P4 runtime inside the box. It never leaves the box. It's just used, and I'll show a picture of the next slide that kind of is an example of that. And the P4 runtime native allows you to have all the benefits of gRPC without the overhead. They're getting really good results with that. Also, another development is this P4TC kernel driver, and P4TC is sort of the kernel equivalent of TDI, and it again is really focused on making sure that we keep that performance, but moving the configuration out of user space, out of the sort of C++ functional interface into the kernel.
Dan, I'm very familiar with that and with TC. And again, having P4 underlying interface replaced from gRPC is a good approach to improve performance. But having it work on non-performant API such as TC is not the way you want to go. And that's why TDI also rings, lit red lights to me.
I see.
From performance perspective, of course.
Yep. Yeah. So we'll get into some of the ways we really solve the performance issues, especially around Dash, which is very performance sensitive.
Okay.
That's a great point.
Right.
It's top of mind.
I think we can go on and we can come back to this, right? We're not going to decide anything today.
Form. Yeah, absolutely. Yeah. Going back to the idea of P4 runtime is at the Overhead conference last year, we presented on this concept where not only are we using P4 to program programmable stuff, we are also using P4 as a contract to organize all these different control planes. So most of these control planes are not using a programmable data plane. They're just doing their thing. FR is routing, strong swan is encrypting, Kubernetes is doing its own different networking functions. And so, we're using the idea of something programmable to be able to stitch together these fixed function control planes and sequence them into something that makes sense, can be debugged and put into a single device. For a single packet, it might go through a table set up by Kubernetes that goes through a tunnel set up by OVS, which set that up through the kernel, which then pushes it through an IPsec transport, and then is load balanced to the next port based on your routing function. So trying to tame this control plane complexity, the solution that we came up with is to use this programmable interface, and P4 runtime has this very nice multi-client server model. So you can have multiple different P4 runtime clients running simultaneously with a single server. And so this is, original SDN OpenFlow models always had sort of a monolithic SDN controller talking to all the different devices. That's wonderful if that's what you have in your network. But as open source doesn't work that way. Open source needs to come from multiple different projects, taking on, different chunks of the problem. And so, we're going to have to handle all these different independent control planes as they live and die independent from one another. And so the three recipes that we've been working on thus far, networking, IPsec, and Kubernetes, leverage this to be able to sequence all of the different pieces together. This is a deeper picture of how we do it. This is yet again another deeper picture of how we do it. I'm not going to go through that. So I do want to give just a quick update as to where our implementation is today. Is that we have a application called Infra P4D. It's based on Stratum. There are P4 programs on the website that do networking, IPsec, and Kubernetes, and we've integrated it with OVS. Inside of it, there's a P4 runtime server, an open config server. The kernel monitor is what is listening to the netlink sockets. We have done the strong swan integration for the IPsec recipe. We are working on the next release to add things like lag and to better align the port configurations using OpenConfig. So that's just a quick update of where we are today. And I'm going to leave this here as just the table that is, something that could be published, is to say, here is the sort of official Psi to P4 mapping table. And we're using the same concepts from pins, where you can use pragmas inside of your P4 to be able to say, hey, I've just instantiated this table, L2 forward RX table, and that is implementing, this Psi call, so that via the pragmas, you can sort of automatically map from Psi to P4, so that you can detect if, okay, this P4 program that you wrote doesn't have any tables for layer 2 bridge. And so when it's running, or even when it's compiled, you can detect that and say, these features will not be supported because you don't have the pragmas necessary to be able to handle the layer 2 table or whatnot. So we have these here in the implementation, just a little different table here. I'd like to introduce Reshma. She has been leading on our side our efforts around Sonic and Dash, and she's going to step you through what we have today in these areas.
Thank you, Dan. Hi, everyone. This is my first time in this forum, so very glad to be here. I just have a couple of slides, so we'll go directly into that. As we all know, Sonic is an open source network operating system that runs on switches in cloud and enterprise data centers. Sonic is currently being extended to support other network devices for edge use cases in edge data centers as IPU with the new Dash initiative. Dash stands for Disaggregated APIs for Sonic Host, and is a community project now, initiated actually by Microsoft. So while the goal of Dash is to standardize methods to program hardware throughout the cloud infrastructure, we also want to unify switch and IPU management with this single management interface using Sonic. And we have brought up Sonic running on IPU today with Debian, and integrated it with our new IPU libsci layer that we implemented, which actually implements Dash Psi. We utilize the IPDK TDI programming interface directly linked into the container in Sonic called syncd, which hosts the vendor SDK. And we utilize the IPDK TDI programming interface to program the Dash P4 table entries, as well as the fixed portions such as port configurations. And in Sonic itself, there is a bit of a change. In data center, service endpoints are spread all across the network for a given service, and we need SDN to control where these services can run and inform the nodes in the data center and map them to the flows to possible backends. So this is the reason to implement the Dash container for SDN management in Sonic that is being worked upon at this moment. And as the Dash Sonic is available, we will be integrating that with our Dash implementation in MevLibSci, in IPO-LibSci. And the use case itself that we have been working on, the Dash APIs are about the this use case that's currently under discussion in the community, which is actually as a starting point to the Dash design. It's called the VNet to VNet. And this mainly addresses the huge cost associated with establishing the first connection, where we want to avoid control plane CPU in the first packet processing. A Dash device, SmartNIC IPU, can handle those rule processing of the first packet to construct the flow entry in the hardware itself. So thus it can achieve multiple millions of connections per second, which is possible with this new construct called add-on-miss that's in the SmartNICs IPU DPUs. And we have implemented the related packet transformations in our Dash implementation. Next slide, please. As we see the standardizing the programming methods for vendors with similar functionalities as really critical for the cloud infrastructure future. And this is achieved via the Dash APIs. We implemented the Dash APIs as part of the newly added MevLibSci layer I mentioned earlier, and on top of the IPDK TDI. This new MevLibSci, the IPU-Sci library, utilizes the TDI APIs to program Dash flow entries, flow rules into the hardware tables. And to simplify the implementation and support of our library itself, we also have this table API interface that's implemented within the IPU-LibSci. It auto-generates APIs based on the P4 program artifacts like the Dash.P4 that we have implemented, compiled for our Mount Evans, by our Mount Evans P4C. But it utilizes the TDI APIs and writes the P4 entries into the hardware. We have, as I mentioned, implemented the VNet use case where there is outbound and inbound routing pipeline as the packet traverses, and we manage the millions of flows and redirect them accurately. The VM to cloud infrastructure traffic could traverse internet or within the private links of the cloud infrastructure, and the outgoing encapsulation could differ accordingly, and the corresponding CA to PA mappings could differ accordingly, and corresponding metering required for billing based on where the packet is destined to. All of that is quite complex pipeline. We have multiple policy tables which are SDN managed that we have implemented, and the card, the IPU card actually manages a set of ENIs, elastic network interfaces based on VMs, etc. Which VMs traffic flows we intend to host within this NIC in the adapter and manage those flows in this adapter. The connection tracking table is arranged based on those except we do not statically carve that out and utilize ENI as a lookup key, and it's very complex because this is a bump in the wire use case, and it utilizes port-to-port as compared to typical end host sort of connection tracking. So we have implemented all of that in the IPO libsci layer, and utilize Dash for we utilize TDI for that programming, which we link directly into the vendor SDK library that we link directly into the syncd container of Sonic.
So earlier it showed Dash directly calling TDI. Here you show that it goes through libsci and in all this. How do I reconcile those two statements?
Sure. So Dash are a set of APIs. They are header files, that describe the packet transformations for all these complex conditions that we just mentioned of ENI, per ENI connection tracking, all that. So the header files, those APIs are implemented in the new IPO libsci layer, and we map that to the backend and program it through the TDI layer.
The libsci is doing the translation between the two.
It is the implementation of those header files, the APIs that Dash describes.
Yep, and it's in that particular implementation, we're just taking those header files and converting them into TDI. That's all it does.
Oh, okay.
Yeah, so for example, we need to implement certain tables. The policy tables, the SDN tables, like for example, the virtual IP address that the adapter advertises to draw the traffic from certain VMs that it wants to manage the flows for, right? That or the VNI based direction that we have, which is dynamically derived direction in the pipeline as compared to anything static, because it's not an end-host scenario. It's a bump in the wire use case. So all these tables are written by the they are SDN managed tables, suppose the policy tables, and we have to implement all these tables. So the software work for implementing Dash Sonic would comprise or fall into these three buckets. One would be the PIFA program itself to fit all these features of CAPA mapping or VNet or VXLAN NCAP or all of those things into the hardware itself, where the Dash.PIFA program will has been written to do that. The second bucket would be the implementation of Dash APIs itself that provides the abstraction from the control plane to what actually happens in the hardware for those packet transformations. So the Dash implementation itself is in the IPO libsci. And the third aspect of this would be to manage the device and implement the control plane itself, which is the Sonic that would do the management, and interface would be the interface between a remote SDN controller and this device, and utilizes the Dash APIs as well to call into the hardware to program them.
So this libsci is implemented today. It is not open source, but we're moving towards getting it open source, and it can be used in both the smart switch and in the standalone device use cases.
Joe, any other questions? I'm not sure if I fully addressed your question.
Yeah, I mean, that's fine for now. Any other questions from anyone else?
Yeah, these features are implemented in P4, and also, the corresponding software implementation to actually map them to the corresponding tables in the hardware, or eventually when we have this in the host P4 DPDK pipeline, we essentially map something like all these different tables in a large exact match or a small exact match or something like that, for example. So all that mapping, the feature implementation goes into the lib side, and we use a TDI interface to program that into the hub.
And you can think of the P4DPDK as sort of like the BMV2 equivalent, is that, we use it as a software model, but it's a decently performant software model. So you could imagine putting it in a real network and having it carry real traffic. It's just not going to go at 100 gigabit. But it's a really great way to get these implementations out there in the open source, people trying them and sort of sorting out the details of the different programs to make sure that we have all of those right without having to have everyone have their different implementations out in the open source for everyone to try. Obviously, that will be better if we once we have our OPI lab, everyone can try out these things on different implementations. But in the meantime, that software model is really helpful to be able to enable that collaboration. I figured we'd take a lot of time, and sorry, Vipin,
we'll do the dash itself next week, Vipin. So if you're ready for that next week, we'll have you go through the dash stuff on the next TSC call. Vipin, you may be double muted. So the proposal, okay, so if we were to have a proposal for OPI, it would be to take to basically say TDI is the standard hardware abstraction. And what else would we need to take? What else would we take? So we basically say, hey, we're going to move some stuff from IPDK into OPI. And again, this is proposal. This is what might be useful. And we would say for Dash, we want to then use that part of OPI as the underpinning for Dash as well, because there's a demonstrated case of it working.
Right.
We could also upstream the some of this code.
So
right. So I think that's the next thing for this is to write down what the actual proposal would be. This is good education. And then we may need to go back to technical discussion to understand why that's the proposal and how it would work. But does that make sense, Dan?
That sounds perfect. Yeah, and that is our proposal in a nutshell, is that all of the code is on offer, and we would donate it to OPI and figure out the how to maintain and keep everything straight between the two. But I think that's pretty easy. It's really we just the process of deciding which pieces we'd want to take and have it be code driven. It's just, here's the code, what do you want changed, what parts do you want, what parts do you want to leave? So everything's on offer. So we'll write that up and make it to make it more explicit, so we can have that more detailed discussion.
Okay. Any other questions on this?
Joe, we were going to have a similar discussion in the API meeting as well.
Sure.
But I don't want to derail that discussion or bring that discussion here. Having said that, I thought we were going to talk about the possible ways of aligning with Dash or
Yeah.
those
So-
things.
So next week, would you
I thought myself and Dan were going to present something this week. So I do have a few things to talk about, exact same topic, but I thought it would be in
let's
the
lead off. So can we lead off with that next week? And so I didn't see you on the call for a while, so and we had this content as well that we wanted to review and understand because it's part of the overall, the overall set of decisions we have to make. So Vipin, would you mind leading off with that next week at the TSC call? Are you available?
I'm happy to. I thought we were going to do it in the API call. That's why I was confused.
Which we could do which in the API call? This discussion?
No, this is
or yours?
like the possible technical alignment, or rather, get to see what options and where do we want to cut ourselves in with respect to Dash. So we
Yeah.
can discuss it now. I mean, it's not a big deal. I don't need to present. I can probably ask some questions and go with that. It's okay.
I think in the API call, we'll get into the dirty details. I wrote this deck just to have it be just an overview for the TSC to just give them the.
Because we're going to have to vote.
Yeah.
Yeah, because we're going to have to vote on the decision, and so we need some amount of education and information to do that, Vipin. But
totally get it. Yes.
yeah, and so maybe you can lead the what does Dash actually need discussion next week. I think that's what we had talked about at the last call. Is you said that you had a fair bit of information and understanding of what Dash actually needs, and
yeah, no, more than what Dash needs. I think Dash team is pretty clear on what they are going after. The use case is clear. The stack is very prescriptive and all that. I think what we need to decide is what is there from the OPI point of view that we can align and or make it synergistic with Dash. That's the main question, in my opinion.
okay, yeah. So that would be a great discussion to have at the next TSC call.
Okay.
Yeah. So we'll tee that up as the first topic for the next TSC call.
Sure.
All right, because I would love to have it right now, but we're out of time and everyone has to run to other calls. So
fair enough. Yeah.
All right. Then so we have our agenda for next week. Thank you, everyone. And we'll continue the IPDK TDI discussion next week.
Thank you.
Thanks.
Thank you.